Hi, this demo is quite technical. In fact, I would give it a nerd meter of about 9 out of 10, but it will most certainly be of interest to you if you want to see how a zero trust approach of ours blocks all unwanted traffic without impeding any legitimate traffic. I'll show you how, if you're the administrator of a backhaul or a business internet connection or even a small network broadband connection, how you can positively stop peer-to-peer traffic, including torrents, whether they're encrypted or otherwise, Skype, or anything else that uses peer-to-peer. You'll stop TOR, the onion router, Siphon, DNS crypt bypasses, outbound VPNs, outbound proxy connections, etc. All this will be done without the use of any proxies, without any layer 7 inspection, and without any man-in-the-middle technology. I'll do a demo for you. What I have here is my lab on this laptop that is logically arranged like this. My MacBook Pro is the hypervisor where I'm recording this video, and I have a guest host that's running the latest version of pfSense with the DNSthingy services installed and registered. I also have a guest version of Windows 7 behind that pfSense, and the default gateway for that Windows machine is pfSense. Now, Eden mode is what we call the combination of when DNSthingy is provisioned for a device in this zero trust model or whitelisting mode, along with a feature that we call don't talk to strangers. And here's what that means. The zero trust model or whitelisting is simply the methodology where you deny all or block all, and then you add selective permissions from there. The don't talk to strangers, or DTTS for short portion, is an approach to offer IP layer enforcement to block DNS firewall circumvention. Now, lots of applications use internal proprietary non-DNS methods of IP lookups, and some do this for good reasons, by the way, and those we'll address with what we call enablers. The DTTS approach will simply block such alternate methods since it creates very short-lived firewall allow rules for outgoing connections. These outgoing rules are based on successful DNS lookups. That's it. Very simple and elegant. So maybe now the title makes sense about operating in a zero trust model as in combination with DTTS we call Eden mode, because in the Garden of Eden is the last time that we had a mostly threat-free world, and we want to get back to that. Let me show you now how my firewall rules are set up in pfSense, and you'll see the usual default allow all for LAN outbound connections is disabled, and that's necessary because the pfSense's GUI firewall rules supersede the internal rapidly changing ones that DTTS creates and destroys on the fly. And as a simple example now, let me show you how it works. If I try and ping 8.8.8.8, I get no response. And this is because a successful DNS lookup did not precede it. So a firewall allow rule has not yet been created. If, however, I try and ping that address by its host name, which happens to be google-public-dns-a.google.com, which does resolve to 8.8.8.8, then I do get the result I would expect. It works just fine. Now my diagnostic log shows that this rule was created and is valid for 900 seconds. And that 900 number comes from the DNS TTL response, the time to live value that Google has published as part of that record. After that time period has expired, the firewall allow rule will be destroyed. Now, established TCP or UDP traffic will keep on working even after the rule is destroyed. So, with all that as a foundation to what we call Eden mode, let me show you that I can easily access the content that I need. As you can see, I can launch my Twitter app, no problem. I can launch Twit Live. I can launch an IRC client without any difficulty. YouTube works as you would expect, with the exception of two things I want to point out. DoubleClick, arguably the world's worst tracker, hasn't been added to the whitelist, so all DoubleClick ads are blocked. Also, we're using YouTube's safety mode, which is forced. Let me take a brief detour. Let's say you have someone who wants to circumvent the DNS firewall and just tries to use quadruple 8 instead, or 4.2.2.1, or some rogue public resolver for that matter that's being changed by malware. Whatever is attempted, they all get answered by policy, no matter what has been attempted. And this is for two reasons. First, you want to prevent circumvention. And the second reason is you create convenience for those that accidentally have left DNS servers set statically for some other network. So you see, we get the same answers no matter where we try and ask the DNS questions, the results are the same. And just like YouTube has DNS-based forced safety mode, Google and Bing have DNS methods we've enabled to force safe search, which nicely blocks adult content. Again, circumvention in this setup is not possible. Now let's try some other apps that in the context of our typical subscriber are not welcome. Like anything, tools depend on context. A hammer can kill a human, but a hammer is also a necessary carpenter's tool. DNSthingy is designed so that a responsible internet connection administrator can prevent that hammer from being misused. So for example, TOR, the onion router. It's a necessary and important tool for any legitimate whistleblower to keep their anonymity, for example. It is not, however, a tool which I want a potentially infected system to be able to use to generate and store a private key on the darknet with the ransomware author. And my own kids also have no business whatsoever exploring the darknet. So when I launch TOR, this is what I want to experience, just a simple inability to connect. What about DNSCrypt desktop client, which also uses alternate ports and servers? Blocked too. What about my outbound VPN connection? No go. No matter what destination or service, no matter what protocol is attempted. Proxies are blocked as well. Even the very popular Chrome extension called Hotspot Shield, as you can see, simply cannot connect. What about zero-day phishing attacks? Let's check PhishTank for some recent submissions, and as you can see, they all get blocked. What you have just seen is full and complete egress control, 100% enforced and based on your allow list, your whitelist. And this is all done without the use of any proxies, without any layer 7 inspection, and without any man-in-the-middle privacy busting technology. So next, typically, the question comes up of how do you build your whitelist? And broadly speaking, there are three methods. The first method is that you can passively log queries based on an initial blacklisting rule set and use that as a base for later culling to convert into a starter whitelist. Number two, you can use adaptive whitelisting as you go, which works by auto whitelisting domains and their dependencies based on a single level crawl, as long as the domain is a legitimate business category, has an actual positive reputation with our own threat intelligence, and there are no current concerns with Google Safe Browsing. You can take a meticulous approach, this is the third one, and manually approve each request. So those are the three methods for building your own whitelist. But the ecosystem does include a few tools. First, we have a Google Chrome extension that is called a block page assistant. And this is an important extension because it has the function of, instead of doing a traditional SSL mismatch ugliness that comes with the SSL-based blocking with a DNS alternative answer, we present you with a very nice, no errors, no privacy warning signs of a block page. The second tool is the mytools.management, which is an internal web service which gives you unauthenticated visibility to your own queries, provided that the administrator of your setup has enabled that. And by the way, it's enabled, it is not enabled by default, but it is easily enabled on a per device basis. And each time a site is blocked or allowed, that result is shown in real time on that live log. Now this can be a rapidly changing list, so it can easily be filtered by a device. In other words, if you have a few dozen devices that you're all watching the logs on and you quickly want to filter down to one, just click the little magnifying glass beside the one that you want to monitor. And this is how you conveniently keep your whitelist up to date and lose no productivity. And by now you probably recognize that this approach, if you're the responsible person for an internet connection, is how you make sure that you allow absolutely no unauthorized exfiltration of data. This is how you make sure there's absolutely no phishing that succeeds of any kind. And you can sleep peacefully knowing that if a threat is brought inside your network through some other vector like an infected flash drive, it is now at least contained. And another time I'll show you how malware and botnet alerts work, and how even weeks later you can identify a threat that attempted to do damage weeks or months ago. It may have been unidentified at the time, but now we can tell you that you are protected against it retroactively. Enjoy.